Hello there, welcome back to the new lecture. So in this lecture we'll discuss duct classification. After the end of this lecture, you would be able to understand the velocity classification, pressure classification, and then we'll discuss the difference between velocity and pressure classification. So let's start. So first of all, here you can see the duct velocity classification. So what is the main purpose of the duct velocity classification? So remember, the duct velocity classification categorize duct based on the speed of air moving through them. Okay, so this will helps in designing duct to minimize noise, energy loss and material cost. So here in that the first one is given here, low velocity system, low velocity duct or low velocity system. So they are categorized by air velocity up to 2000 feet per minute fpm. Generally this velocity, low velocity system, generally used in residential and commercial HVAC system where noise reduction is critical. So in that area, generally the velocity, we have to use the low velocity system. Okay, example, a low velocity duct in a residential home supplies air at 1500 fpm, ensuring quiet operation. Okay, now the next one is the medium velocity system. So here they are categorized by air velocity in the range of 2000 to 3000 fpm, and this minimum velocity duct system generally common in larger commercial or industrial system for balancing airflow efficiency and noise. Okay, for example, a duct in an office building delivers air at 2500 fpm to maintain a higher air exchange rate. Clear? And then we have a high velocity duct system. They are categorized by air velocity greater than 3000 fpm. So this high velocity duct system used in high rise buildings or specialized industrial application where space saving or high airflow is needed. Example, a high velocity duct in a hospital HVAC system operate as 3000 fpm to ensure rapid air distribution. Okay, so these are the what here we have discussed the duct velocity classification. Okay, here see the some point, important point is given for velocity classification. Suppose the low velocity system generally is used in most air conditioning installation because it is quieter, as lower friction losses, lower fan power and lower air leakage. Small 2 and 3 story building are normally low velocity. Okay, a velocity of 1000 to 1500 fpm for main duct and a velocity of 700 to 1000 fpm for the branch takeoff are recommended. High duct velocity result in lower initial cost but required increased fan static pressure, therefore resulting in increased operating cost. So often these need additional noise attenuation used for noise silencer and are not suitable for comfort application. Okay, so this is all about the duct velocity classification. Next, here we'll discuss the duct pressure classification. So here this duct pressure classification categorize duct based on the static pressure they are designed to handle. Okay, so in that the first one is the low pressure duct. Okay, the term low pressure applies to system with fan static pressure less than 3 inch of water column. Generally the duct velocity are less than 1500 fpm. So remember the low pressure duct system common in residential and light commercial HVAC system. Okay, then we have a medium pressure, means the medium pressure applies to system with fan static pressure between 3 to 6 inch of water column. So this medium pressure duct used in large commercial and industrial building for more airflow capacities. Then finally the high pressure duct, okay, system generally applies to system with fan static pressure between 6 to means above 6 inch 6 to 10 inch water column. So typically this type high pressure duct system used in industrial system, okay, high rise building or clean room requiring precise control. So in that we are using high pressure duct system. Here some important points is given. General good engineering practice, as per general good engineering practice, are use of medium pressure classification for primary air duct work, fan connection, riser and main distribution duct, and use of low pressure classification for secondary air duct work like runoff or branches from main to terminal boxes and distribution devices. It is given here, okay, where you have to use the low pressure classification and medium pressure classification. Now let's see the difference between velocity and pressure classification, duct velocity and duct pressure classification. So the first point is given, duct pressure classification influences the duct strength, deflection and air leakage, and duct velocity classification influences noise, vibration, frictional losses and fan power. So these are the main difference between velocity and pressure classification. Now the topics which we have covered in this session. First of all, we have discussed in detail about the duct velocity classification. Then we have discussed the duct pressure classification, and I have also shown you the basic difference, okay, between the velocity and pressure classification. Hope all of you enjoy this session. See you in next one.